Hello, ladies and gentlemen. I hope you guys are all doing okay today. Welcome to the first video for you guys. Today, what we're going to be talking about two different sections, but basically they're the same thing. So we're going to be talking about section 7.2 and 7.1 or 7.3, which involves multiplying polynomials. Okay. So essentially, in order to multiply polynomials, it's just a glorified version of the distribution property. Basically, what we're going to be doing, we're going to be taking everything from the first parentheses, and we're going to distribute it through to the second one, and then we are going to combine like terms. All right. As you can see here, I have 8 questions that we're going to work on together. Some are a little bit more challenging than others, but either way, we're going to get them done. All right. So, first up, example 1. So example 1 here says we have x minus 4, move this over, times x plus 7. Now, as I said in the intro, basically it's a glorified version of the distributive property. I'm going to take this first term, I'm going to take this x, times everything in the second parentheses. I'm going to take the second term, this minus 4, distribute it through, and now we're going to multiply them all together. So x times x is x squared. X times positive 7 plus 7x. Negative 4 times x is negative 4x. Negative 4 times 7 minus 28. Now we just need to combine like terms. Okay, x squared, that's the only one that's an x squared, so that's going to stay x squared. 7 plus negative 4, positive 3x. There's nothing else without an x, so we just have minus 28 at the end. So, x minus 4 times the quantity of x plus 3, distribute it out, bam, combine like terms. We are left with a trinomial in its wake. Okay. So this one wasn't too bad, pretty straightforward, not a whole lot to it. Let's make it a little bit more interesting. Okay. So looking at this, the next one. 3x plus 5 times 2x plus 11. Again, just like last time, we're going to distribute everything from the first parentheses to everything in the second parentheses. Now, at any point, you can pause this. That's more than, well, obviously I can't tell if you don't or not, but please do so. Go back, look at it. If you have questions, please ask me. So we're going to distribute this 3x through. And then we're going to distribute the 5 through to the other parentheses as well. So first up, 3x times 2x, multiply the coefficients. 3 times 2 is 6. X times x is x squared. Next, we have 3x times 11. 3 times 11 is 33. And x comes with. Now we're going to distribute this 5 through. 5 times 2x is plus 10x. 5 times 11 is plus 55. Now we just need to combine like terms. 6x squared stays 6x squared. Plus 33x plus 10x, they both have just x. 10 plus 33 is 43. 55, well, that's just 55. So the answer to this one here would be 6x squared plus 43x plus 55. Okay? So when we multiply these, we are trying to get rid of the parentheses. These first two are going to be the easiest two. Now we're going to get into the little bit more challenging ones. The reason why they're challenging is because they are no longer just numbers and x. I'm going to start throwing some different things in there because there are different things that you can do with this. Okay, let me get it so that way we can see it. So for the third one, you could have 2 different variables in there. So here we have 3x plus y, or plus 4y, times 6x minus y. Now, the numbers inside may be different. They may have extra stuff, but the process stays the same. We are still going to distribute. Okay. 3x times 6x, just like last time. 3 times 6 is 18. X times x is x squared. Here's where it gets interesting. 3x times negative y. Well, I see that as a negative 1. 3 times negative 1 is negative 3. X times y, well, we can't actually combine them, so it stays, well, 3xy. Now we go to the first ones. 4y times 6x. 4 times 6 is plus 24. X times y is still xy. And last but most certainly not least, 4y times negative y minus 4y squared. Okay? Now it's just combining like terms. There's nothing else with an x squared, so we're going to have 18x squared. Negative 3 plus 24 plus 21xy. That's the only one with a y squared, so we have minus 4y squared. Pretty straightforward. Nothing too terrible about it, just a little bit time consuming. Okay. That one had multiple variables. This next one, well, you notice two terms, we have a binomial times a binomial. When we're multiplying polynomials, there are more than just binomials available. There are trinomials that we can use. So I will apologize, this one is going to be the longest one so far. We are going to take a binomial, x minus 5, times a trinomial, 3x squared plus 5x minus 1. So take a second and think. In order to multiply these, we are going to have to distribute. Okay, so this x is going to be times everything. Now there are 3 terms in the second set of parentheses, so we have to multiply it to all 3. This minus 5 is going to be multiplied by everything. Again, there are 3 terms. We're going to multiply it by all 3. So now we have x times 3x squared. That is going to be 3x to the third, because we have 3 x's. 3 times 1 is 3. X times x squared, that's where we get the x cubed. X times plus 5x, well, 1 times 5 is 5. We have 2 x's, so it's going to be x squared. X times negative 1, self-explanatory, negative x. Congratulations, you just took x times all that. Now we got to take negative 5 times all that. Negative 5 times 3x squared is minus 15x squared. Now I'm going to move down to here, but we're still on the same steps. Negative 5 times positive 5x, negative 25x. Negative 5 times negative 1 plus 5. Now, just like before, we combine like terms. This is the only one with an x cubed, so we have 3x cubed. Positive 5x squared, negative 15x squared. 5 minus 15 is negative 10 x squared. Negative x minus 25x, negative 26x. And then we have plus 5. There you go. So we can do a binomial times a trinomial. We just distribute all the way through. We can do the same thing if it was flipped. We would just take the 3x times everything in the second one. And then we take the 5x and all the others. Okay. I want to try to keep this video underneath 15 minutes. So we're going to jump to number 6. Now, if you weren't paying attention at the start, number 6 was 3x minus 8 times 3x plus 8. Now, this one might look a little different for you because we got 3x and 3x, but here's the difference. We have a minus 8 and we have a plus 8. Basically, anytime we have something like this happen where the numbers are all the same, 3x and 3x, 8 and 8, but the only difference is the sign in between them, there's something special that happens. So what we're going to have to do to see what this special thing is, well, we're going to have to distribute. So I'm going to distribute this 3x through, and I'm going to distribute this minus 8 through. I know, more multiplying. 3x times 3x, 9x squared. 3x times positive 8, 3 times 8 is 24, and the x comes along for the ride. Now we have negative 8 times 3, minus 24x. Ooh, interesting. And then we have negative 8 times 8, it's minus 64. Now look to see what happens when we combine like terms here. We still have the 9x squared plus 24x minus 24x. 24 minus 24 is 0. They cancel each other out. So therefore, what we are left with is the minus 64. Now, every other time that we had done this, a binomial times a binomial gave us a trinomial. This is a special circumstance called the difference of perfect squares. If your first term in each of them are the same, if your second term in each of them are the same, the only difference is the sign in between the first and the second terms of the binomials, your middle parts will cancel out. And we are just left with 3x times 3x and negative 8 times 8. These are really nice. This is a really important pattern for you guys to remember. Okay? So, first term's the same, last term's the same. Only difference is the part in the middle. When you distribute, the middle part will cancel out. Bam, you're just left with 2 terms. Okay. Last one I want to do with you involves some squaring. Because how can you have multiplying if you don't have squaring? Or I guess I should say, how can you have any sort of exponents without multiplying? Okay. Last one we are going to have. No, let's do this in purple. 13t minus 8m. And we're going to square it. Now, the reason why I saved this one for last is because this one takes the most thought. Now, some of you may think right now, oh, we can just square this, we can just square this, boom, we're done. That would work if this was a monomial inside here, because then it'd be just like chapter 6, we just square the stuff inside, done. Problem is, it's not a monomial. With this minus, it's a binomial. So what it means when we square something, we take it times itself. So we have 13t minus 8m times 13t minus 8m. When we square a binomial, this is what we get. Now we're back to multiplying binomials, so we are distributing. We're going to be doing a lot of distributing. 13t times both of them. Negative 8m times both of them. Now notice the difference between this and the previous problem. Yes, the first terms are the same. Yes, the last terms are the same. But the difference is the ones in the middle are now the same. They're not the opposites. So that trick we just learned will not work for this one. So let's multiply this out. 13t times 13t is 169t squared. 13t times negative 8m. Let's see, 13 times negative 8. 10 times 8 is 80. 3 times 8 is 24. 80 plus 24 is negative 104. We have both t and m with it. Okay, same thing we just did. So I have minus 104 tm. And last, but most certainly not least, negative 8m times negative 8m is minus 64m squared. So now we just combine like terms. This is the only one with the t squared, so we have 169t squared. Both TMs, negative 104 minus 104 is negative 208 TM. And then we have the minus 64 M squared. Multiple variables, you got a squared. Yes, 13t squared is 169t squared. Negative 8m squared would be 64m squared. But this stuff in the middle would be what we would be missing. So make sure, if you have a squared, you write it out as two separate binomials and then distribute. All right, I kind of failed at my 15 minutes. We're at 17 currently. One of these times I'm going to figure out something for you guys to send to me for making it all the way through the video. You know, for extra credit, if you made it all the way through to the end here, send me an email saying what your favorite kind of pop, drink, tea, Gatorade is. I'm interested in seeing it, and I'll give you guys a few extra points if you do it and made it all the way through. All right. Hopefully you guys have a great day, and I will talk to you later.